Hello everyone. Okay, so this is part 2 of stoichiometry. Sorry it took me a while to create it. It's been a while. I've been working a little hard on, pretty hard, on making this video, so let's go ahead and start. Alright, so, stoichiometry. We recently went over how to define limiting reactants, what is limiting reactant. We went over like a chemical reaction in general, what that is. We also went over briefly how to go from grams to moles. Today we're going to go ahead and add a couple more things. We're going to go ahead and find a limiting reactant through actual mathematics, through actual chemistry math. We're going to go ahead and find percent yields as well. And then we're going to go ahead and top it off with a chemical reaction where you have to actually figure out numbers by yourself. We're not going to give you numbers. We're going to give you some vague items, and you kind of have to figure out the information for yourself. Basically, this will be the more tougher of the questions, not the hardest, however. Like the super difficult questions, those are to come on worksheets. The comprehensive worksheet that's being created at the moment. Basically, these are like the medium questions. These are also questions we've done in class. They are the your turns. I'm going over the your turns basically. The your turns here, basically they're going to be used just because you guys don't know how to do stuff. You guys don't do these in class, so this is my way of forcing you to do them. Unless you don't want to listen, go ahead and close the video now. Anyway, let's go and start. So the first one is actually slide number 3 on the latest PowerPoint full notes, dated October 22nd. So 22nd. So go ahead and check that out. Slide number 3, we look at this chemical reaction. Let me go and write it out. C12H22O11. This is also known as sucrose plus KClO3, and this yields some carbon dioxide, which is what we exhale, hooray, plus H2O, which we also exhale, kind of cool, plus some potassium chloride, KCl. Alright, so basically here we're going to go ahead and do a couple of questions to figure out how to do math, basically. So I'm going to ask you how many grams, I'm going to write this in a different color so you know what I'm asking for, grams of reactant after I mix, so after I mix 2.5 grams of sucrose and 25 grams of KClO3. So these are reactants, as you can see by the chemical reaction. Both of these are up here, so reactants. Basically your job is to figure out how much is left after this. So basically that implies one of these is a limiting reactant, while the other one is not. That's the one we're gonna have excess of, and we have to figure out which one's which. And we've basically given you more than enough information to figure that out. We've given you the chemical formulas, so basically you have to go and figure out the molar mass. There's two ways of doing this. One, if you're lazy and don't want to look at the full notes, you can go ahead and actually pull out a calculator and figure it out, the molar masses. Or if you're not lazy, or actually if you're lazy enough to not do the math, go check. So either way, you're lazy, hooray. If you're lazy to not check the notes, go and do it on the calculator. If you're lazy and don't want to do it on the calculator, check the notes. The notes do have them. I'm going to do the calculations, assuming that I've done the calculations for the molar masses, but you must do that yourself. Okay, we're not, a lot of the times we won't give that stuff to you. If we do, the person who wrote that question is a very nice person. Because honestly, if it were up to me, I would never give any of you any of that stuff, just because of the fact that you guys know how to find it, so go find it, All right, well, basically, I want to know. I'm gonna erase some of this, so write it out, take a picture of it on your phone, whatever. Hooray! Don't text while watching this video. Close your Facebook page. Hooray! I'm gonna erase this so we can actually do the math portion. But there's two parts to this question. If you're actually looking at slide number 3 on 1022, full notes. I'm doing the first problem, so number 1. It just asks how many grams of reactants remain after I mix 2.5 grams of sucrose and 22 grams of KClO3. After they react, how much of my reactant, we're not telling you which one, but how much of the reactant is remaining. So because we're not telling you which reactant is remaining, you have to figure that out for yourself. So we're going to go and do that by actually taking a peek at what is the limiting reactant. So that's the first thing you do. The first thing you do before that is actually check if your reaction is balanced, which in this case it's not. You actually have to balance your reaction before you do anything. So I'm going to let you guys go ahead and do that on your own. You guys should know how to balance reactions. If you don't, or balance chemical equations. If you don't, I'm not going to go over that because we've gone over that enough in class. Dr. Van Dorn has done it in her office hours, and there's a crap ton of videos online. You can figure this out. So, and in office hours, we do this. So basically, yeah, I'm not going to go over it. So, well, I'm just gonna write it out. So this is an 8. This is a 12, 11, and 8. So the first one is just 1, right? 1 sucrose. We don't normally have to write the 1. We can. It's proper to not write it, but whatever. And let's go ahead and do the math for this. So I'm going to go and erase this. Sorry, my erasing skills are like horrible. Okay, I think that's erased. Yay. So first things first, find limiting reactants. After you balance, that's the first thing you should do, especially when we give you grams. Most likely you're going to go from grams to moles. So, or milligrams to grams, then grams to moles. So basically, let's go and do that for both. Let's go and start with sucrose first. I gave you guys 2.5 grams of sucrose. I'm going to go and write in white to see if this works. Oh, it does. Cool. So 2.5 grams of sucrose. I'm going to write SUC for sucrose, just because if I write sucrose out for all of this, I might, actually no, I'll just write it out. Sucrose. Okay, and that's just going to be over 1 because this 1 is arbitrary. It's just like a fraction. Like the number 5 is equivalent to 5 over 1. Hooray. Big whoop. So we have 2.5 grams of sucrose over 1, and actually I'm going to go ahead and I'm going to fix this. Over 1. And we're going to go ahead and convert it to moles. The way we do that is we actually use the molar mass, right? So the molar mass for sucrose is 342.2 grams per mole. It is a conversion factor, right? It's 342.2 grams for every 1 mole. But we want to get moles on top, right? Because we want to actually cancel out this grams. So if we have grams on top, we have to have grams on the bottom. This is the stuff from first exam. But basically, I'm just going to put the 342.2 grams on the bottom. So 342.2 grams of sucrose for 1 mole of sucrose. Please notice how I'm actually writing out moles of sucrose, grams of sucrose, etc., etc. That's important. At that point, we're going to go ahead and actually... let's see. Actually, that's it. So you have moles of sucrose, and you have grams of. So we went from grams to moles. All you're going to do now is you're actually going to go and cancel out grams of sucrose, and you're going to find your limiting reactant. I know the answer key on the PowerPoint has a little different. You can do it that way. The answer key basically requires you to actually figure out the number of the grams of CO2 that you're going to get. Actually, let's do it that way. Why not? So, okay, after this, we found moles of sucrose. We're going to actually continue the reaction. We're going to actually find the grams of CO2 that we're going to get. So, in that case, we actually have to sit there and go, okay, well, 1 mole of sucrose equals how many moles of CO2? Well, we have our balanced reaction. We see here that there is a 1 right here, so 1 mole of sucrose equals 12 moles of CO2. So that's going to be where we do our conversion from products or from reactants to products. So basically we're going to have moles of sucrose on the bottom. So 1 mole of sucrose equals 12 moles of CO2. And then from there, we're going to go ahead and finish up the reaction by going back to grams. Just because CO2, we might as well go back to grams. Molar mass for CO2 is 44.01. So I'm going to go and multiply by 44.01 grams for 1 mole. And I get a number of 3.86 grams. Grams of CO2. Alright, so we're going to go and do the same thing, but for KClO3 on the bottom, just like right below it. So for KClO3, we have 25 grams that we've been given. So 25 grams of KClO3 over an arbitrary 1 times the molar mass, right? Because we're going to go from grams to moles. We have to divide by molar mass. So the molar mass is 122.6. So that's 122.6 grams for 1 mole, right? Because that is a conversion factor. Next, we're going to go from, so now you have moles of KClO3, whoops, right? And we have grams of KClO3. Oh my god, I can't do this. KClO3. So we're going to go, oops, hello. We're going to go and cancel out grams, right? So now you have moles of KClO3. We're going to go ahead and actually jump ship from reactants to products. At that point, you have to use the molar ratio, which you have because you balance a reaction. In this case, 1 mole of KClO3. Oh, but wait, look at that. We don't actually have 1 mole of it. We have 8 moles, right? We have 8. There's nowhere in this reaction that we have 1 mole. So we can't say 1 mole. So that's actually kind of wrong. So we're going to go to restart and write an 8. So be careful, guys. You got to look at your molar ratios for this to work. So 8 moles of KClO3 is equivalent to 12 moles of CO2. CO2. So at that point we can go and cancel out moles of KClO3. Now we're on moles of CO2. We're going to go and convert back to grams, which we already know the molar mass of that. We're going to multiply by 44.01 grams per 1 mole of CO2, and this equals 13.5. 13.5 grams of CO2. So basically this shows, at this point you just look at it and say, okay, well, which one is limiting? Well, I have less CO2 coming out of this one, the top one. So sucrose is my limiting reagent, just because I have 2.5 grams of sucrose versus 25 grams of KClO3. Now I have to do the math to figure this out, but the math here shows that because sucrose, the 2.5 grams of sucrose produces only 3.86 grams of CO2 versus 13.5 grams for KClO3, then sucrose is my limiting reactant. That's literally it. So I know that that's my my limiting reactant, and basically from there I can move on. And actually at that point you kind of sit there and know, well, I actually know my limiting reactant, and I know my theoretical yield. My theoretical yield for 3.86, that's my theoretical yield for grams of CO2. Just so you know, it's kind of cool. Moving on, however, you can kind of see that, okay, well, I have, I found my limiting reactant, so I know that it's, I can't words today. I know that it's, sucrose, so I have to actually find the number of grams that KClO3 is used. So basically, I sit there, I'm going to go and erase all of this. That the reaction's gone too, so if you don't have it, go ahead and write it on a piece of paper. So I actually kind of have to sit there and write out the math for KClO3 and determine the number of moles of or the number of grams of KClO3 that's actually going to be used. So to do that, I'm actually going to have to use sucrose, right? So 2.5 grams of sucrose, SUC, over 1 times the molar mass, right? I'm going to go and convert the molar mass, convert to moles using molar mass. So it's 3.42, 342, that sounds more right. 342.2, that's grams for 1 mole, times, and now I actually have to sit there and say, well, how many moles of KClO3 do I have for a mole of sucrose? Well, and that's actually kind of important why we write moles here. So this is mole of sucrose. I have 1 mole of sucrose for every 8 moles. And I'll explain why I got 8 moles of KClO3. If you look in the chemical reaction, it's 1C12H12O11 plus 8ClO3, right? That 8 that we used to balance our equation, that's saying that for every 1 mole of sucrose you're going to use 8 moles of KClO3. Basically from there, you've converted from moles of sucrose to moles of KClO3, which is what we want, but now we want grams of KClO3, so we're going to go and use molar mass and convert back to grams of KClO3. So let's go ahead and do that. Molar mass is 122.6 grams of KClO3 for 1 mole of KClO3. Oops. Go ahead and cancel out the moles of KClO3. You're good to go. The number you get is exactly 7.165 grams of KClO3. So that's how much is used, right? Because we're using that in relationship with this 25 grams of sucrose. Okay, so because that's our limiting, we start off with this, and then we convert and say, well, if I used this many grams of sucrose, then how much KClO3? That's why we use this right here. That's the number of moles of KClO3 per mole of sucrose. And at that point, this continuing on talks about how much not sucrose we used, but how much KClO3 we used. So because we find out how much KClO3 is used, well, we started off with 25 grams, right? We started off with 25 grams to start, and we used up 7.165. Well, if I want to know how much I'm remaining, don't we just subtract these two numbers and get 17.8 grams? And oh look, that's my answer. Done. Yay. Sorry I write diagonally. My iPad's kind of like in a different position, so it's kind of awkward to write. But yeah, that's really it. It's nothing too crazy. It looks really daunting, believe me, I understand. It looks super daunting, but if you know why you're doing each step, this becomes a walk in the park. I guarantee you. Like, you'll sit there and be able to do this in your sleep. But you have to know why you're doing each individual step. If you don't know why you're doing it, why are you doing it? Basically, if you don't know why you're converting from grams to number of atoms, why the hell are you going to do it? Basically is my question to you. But that's really it. Let's go and go to the second part of this question. So the second part of this question says, if 2.2 grams of CO2 are produced, what is the percent yield? So yeah, I'm telling you that 2.2 grams. Excuse me, guys. If 2.2 grams of CO2 are produced, then what is the percent yield? So for that, I need to figure out what 2.2 grams even is. So the 2.2 grams. So look at slide number 6, guys. 2.2 grams of CO2 basically says that's my actual yield. That's what I actually produced. And I want to know percent yield. Well, to do that, I need to figure out a theoretical yield, which is what we do with math. If we do math on like stuff like this, like if we do math on a board or on a piece of paper, that's where we're calculating theoretical yield. You cannot calculate an actual yield using math. The only way you do that is if you have a theoretical and a percent yield and you're finding an actual yield that way, or if you're actually in a lab doing an experiment and actually get a certain gram of product. There's no way of calculating it out of moles and other nonsense. There's no way, because that's not the definition of an actual yield. Actual yield is, in an actual experiment, what did you get versus what you could have gotten, like if you were perfect, which no one is. So to do this, we're going to go and start out with 2 because we know our reaction, we know that sucrose, which is sugar, sucrose is our limiting reactant. So we're going to go and continue with that process. We actually did this calculation earlier, but we're going to do it again. So 2.5 grams of sucrose over 1. We convert that to moles because that's what we've always done. And the molar mass of that is 342.2 grams per mole of sucrose. Sorry if my handwriting is like atrocious, but you guys, I'm telling you what I'm writing, so hooray. So we have moles of sucrose. We're going to now figure out the moles of CO2 that we're going to get theoretically, in which in this case we need to go from reactants to products. To do that, to jump ship, you have to use the molar ratio. I've said that a couple times. Hopefully that makes sense and I'm being repetitive and it's important, so know it. To go from reactants to products, you must jump ship, which means you have to use a molar ratio. To jump ship from anything, to jump ship from one reactant to another reactant, or to go from a one reactant to a one product, you have to use a molar ratio by balancing a reaction. That's why if you don't balance correctly, you're screwed. Like you'll get a very wrong answer and then you're gonna hate your life. So we have this, right? If you look at the previous chemical reaction, we know that for every 1 mole of sucrose, we have 12 moles of CO2. Whoops, that's CO2. Right, so now we've jump shipped from moles of sucrose to moles of CO2. To get from moles back to grams, we're going to go ahead and convert to grams using the molar mass, which in this case is 44.01 grams for 1 mole of CO2. And moles of CO2 cancel out, so we now have grams of CO2. So our theoretical yield, is equivalent of CO2 is equivalent to 3.86. That's just the solution of all of this. That's 3.86 grams. Basically, percent yield is simply actual over theoretical, not theoretical over actual. It's actual over theoretical, okay? If you do it the other way, you're going to get a wrong number and you're screwed. So it's actual over theoretical times 100. You do this in class, guys. When you guys get an exam back and it's like out of, 70? Let's say it's out of 70. And you say, oh, I got a 61 out of 70. Well, 61 is your actual, 70 is the total that you could have gotten if you were in a perfect world and you knew everything, times 100, and you get, let's see, 61 over 70. Okay, yeah, you get an 87%. 87%. Let's go make that full screen again. So you do this every day. You do percent yields every day when it comes to your actual lives, because that's how you figure out what you got on a certain assignment. And you can say, oh, that darn teacher gave me a friggin' B. Screw them. Blah blah blah. Okay, in this case, we have our actual yield. We were given that. That's 2.2 grams that were produced. 2.2 grams of CO2 were produced over our theoretical, which we found using awesome math called stoichiometry, or as some people call it, stoichiometry, and I'm like, no, it's stoichiometry. So theoretical is 3.86 grams of CO2 times 100. That's just to convert from a decimal to a percent, if you didn't figure that out. And your answer is 56.99%. This is not equivalent to 57%. So being as precise as possible is important. This is the correct answer. This is not. You were not 57% there. You were 56.99% there. We don't round. Rounding is good, but not to like a whole number. It's kind of weird. You like to have decimals because decimals are important for chemistry. But that's basically it. What else was I going to do with you guys? I was going to do one more. But I might not. I'm going to go and let you do the other your turn. The other one I was going to do was slide number 9, where it has a percent yield. It gives you an actual, and you're supposed to find a theoretical and then figure out stuff from there. I'm not going to do it because that seems like a more challenging problem that I want you guys to be able to do on your own and logic out on your own. If you have questions about it, come to our office hours. You have a whole week before the exam, so you should be fine. If you have any questions, go and put them in the comments below. Please thumbs up, subscribe, blah, 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 blah. I don't really care. See you guys in class. Thank you all, and thank you all for your attention, and you guys have a great day. Good luck studying.